So good day everyone. This is mathematical intelligence constraint mass intellectual tutorials, and today we are going to be looking at mapping and functions. Mapping and functions. All right. So first of all, what is a map? Now, a map is a rule, or will I say an association between two sets. I can put it that way. A map is like an association, or is an association between two sets, as a relation between two sets. Map and function, they are literally almost the same thing, but just a little difference, which I'm also going to expose to you in this video. So let's quickly look at this. Let's say we have a set A and also a set B. We can have something here. Let's say we have A, we have B, we have X, we have Y inside the set. When you have something like this is called a map. I can think now. This is called a map, whereby you have what? Two set A and B, where element of set A is being mapped to element of set B. We call it a map. That is an association between two sets. That is, A here is associated with X and B here is associated with Y. So this is an example of a map. Now, more things to know about mapping here. Let me bring a bigger diagram. Let's say we have a set A here and we have a set B here, and this A here, and then this is more the way it's more like written. Let me give an example, more better example here. Let's say we have something like, let's say we have A here, let's say we have B, sorry for using A, B, let's say we have C, and let's say we have X, let's say we have Y, and let's say we have Z. I get it now. So when you map from here to here, we have like an arrow like this. We map from here to here. We have another arrow like this. We have map from here to here. We have another arrow like this. Now, this here, what we have here is called a map, like the previous example. And I also want to say that this here, your set A here is called the domain, while set B here is called the co-domain. I get it now. Your set A here is a domain, while your set B here is called the co-domain. This is, all these things are just still a map. I get it now. So set A is the domain and set B is the co-domain, where A is mapped to X, B is mapped to Y, and C is mapped to Z. I get it. So that is how it is. So C is mapped to Z. I get it now. So this set A is the domain and set B is co-domain. Why? Because if you look at it here, you see that I drew an arrow, a kind of an arrow here. That is, it's showing that it is coming from A and going to B. That is coming from set A going to set B. That is why A is the domain. I get it now. I get it now. Because of this arrow here, it's coming from set A and going to set B. That's why A is the domain and B is the codomain. I get it now. That means you see that the element A here is going to the element X here, the element B here is going to the element Y, the element C here is going to the element Z. So this is why A is the domain and B is the codomain. But another example whereby it is going from, maybe it's going this way. I get it now. Whereby it's coming from set B going to set A. Then this B here will be your domain and your A here will be your co-domain. So the position of domain and co-domain is not necessarily that the first side is the domain and the second side is the co-domain. It is depending on where it is coming from. I get it now. The arrow, that is, if the arrow is coming from A to B, just like from set A to B, then A is the domain and B is the co-domain. So having known what a domain is and also what a co-domain is, then from there we can write on. Okay. All right, so let's quickly look at some types of mapping that we have, also basically function also from type of mapping that we have. So let's look at some type of mapping that we have, types of maps. So for some types of map that we have, let's start with the first one here, which is we have one-to-one or injective. One-to-one, or we call it injective. surjective. Right. So we have one-to-one mapping or injective mapping. What does one-to-one mapping or injective mapping says? It's talking about when you have a set A and we have another set B. I get it now. So one-to-one mapping is saying that, let's say we have X and Y. Let's say we have A and B. Let's say we have going from here to here and going from here to here. So one-to-one mapping is saying that every element in your domain, distinct element in your domain, this is the domain, this is the codomain, has distinct images in the codomain. So what am I saying? No, I talked about domain and codomain, but I did not talk about images. I did now. So this is X here is the element, Y A here is the image of what X. I did now. Y here is the element. You get this better when you move to function, and B here is the image of what? Of Y. I get it now. Y, everything here, A and B, is called the range. I get it now. You get it now. All right. So now X is mapped to this. So one-to-one or injective mapping is saying that distinct element here has distinct images. What are you saying? One element here has its own image separate, and that element here has its own image separately. I get it now. So this is what this thing is trying to tell us. An element here has its own image separately. Another element has its own image. All the elements here has their own different images. So that's what one-to-one is saying. All the elements here in your domain has their own different images. You cannot have something like this. If you have something like this, say we have something like 1, 2, and you have 3, 4, and then you have one map to. This is also possible under mapping. You see here now, this image of 1 is 3, image of 2 is also 3. So if you look at this example here, all elements in your domain, this is not a one-to-one. Reason that elements in domain as they don't have separate images in the codomain. That is, all the elements here are not having different images. So that is, if you have a long mapping and then you have at least one element in your domain, or at least two elements in your domain that is mapped to the same image, then it's not a one-to-one mapping. So each element has their own separate images. Each element has their own separate images, and that is what one-to-one is saying. All right, so quickly let's move to the next thing here. All right, so now number 2 is the second one, which I'm discussing, or the second, I'm basically discussing just 3. So second one is onto mapping. Right there now, we have onto mapping. So what is onto mapping? Onto mapping is just saying that every element in your code domain is an image of elements in your domain. So it does not matter. Let's say we have A, B, C. Let's say you have 1, 2, 3. So let's say this is mapped to this. Let's say this is mapped to this. This is also mapped to this idea. So now onto mapping is just saying that elements in your code domain, all the elements in your code domain, that is, all the elements in your code domain is an image of an element in your domain. So that is what onto mapping is saying, or it's also called surjective. Surjective. Idea. It's also called surjective mapping. Idea. So, or function. Basically they're almost the same example when it comes to types, when it comes to function also. Now, surjective is saying that what every element in your code domain, either all the elements in your code domain 1, 2, 3 must be an image of elements in your domain. I get it now. Every element in your code domain must be an image of elements in your domain. That is, this must be an image of something. This must, for all the elements here, must be an image of something in the domain. And we already know what images. Images are the ones in your code domain that is mapped to something identical. So that is what is saying, that all the elements in your code domain must be mapped to something in your domain. Look at this. Let's say we have something like this. Let's say we have 1, 2, 3, and then you say you have A, B. Let's see, let me clean this off. Let's say you have A, B, and C. Right there. So let's look at this map to this and this map to this. Right there now. So if you look at this very well now, your all the elements in your codomain is not an image of elements in your domain. So this is not a surjective mapping. Surjective mapping is saying that all the elements in this codomain must be mapped to something in your domain. That is, it must be an image of something in my domain. I get it now. That is what surjective mapping is saying. But here now, if you look at this here, B here is not mapped to anything. So this is not a surjective mapping. Meaning that what all the elements here are not images of elements in my domain. Do you get it now? So that's why this one is not a surjective mapping. But this one is still one-to-one. That is, a mapping can be one-to-one and may not be onto or surjective. I get it now. What it's saying is that here now, this is one-to-one. Reason being that what all the elements in my domain has separate images in the codomain. One has its own image, two has its own image separately. I get it now. All the elements here has their own separate image. That's what one-to-one is saying. So this is one-to-one. But yes, this is not onto. Reason being that what this one here is not mapped to anything. Reason being that what all the elements here are not images of something here. That is, all the elements here are not mapped to something in the domain because of this last element that's not mapped to something. This one is mapped to something, it's mapped to something. This one is an image of something, this is an image of something, but this one is not an image of anything. And for onto mapping, everything here must be an image of something here. I get it now. So that is what onto is saying. And the last type of mapping for today, probably in the next video, we'll look at functions properly. And the last type of mapping today is just like a mapping that joins both of them. It's a mapping that joins both of them, and that is what we call a bijective. Bijective. Bijective mapping. Same example in mapping is literally same type of types in mapping is also the same types in function. They are literally almost the same thing, but just a little difference. So bijective mapping is a mapping where it is both onto one-to-one, one-to-one, onto mapping, and I've written onto already, and one-to-one. That is bijective. It is both onto and one-to-one. That is, it is both example 1 and example 2 all together. So what am I saying? Let's give an example here. Let's give another example here. Sorry about my circle. Let me see if I can get one beautiful circle here. Let me cancel this. Let me see if I can get one beautiful circle. Okay, let me see. All right, so one-to-one. Let me see if I can get one beautiful. Yes, I got it. Let's see if I get another one. Okay, this is fine. This is fine by me. All right, so one-to-one. Now one-to-one is saying this is A and this is B. Right there now. This is A, this is B. So bijective mapping is saying that all the elements here, it is both one-to-one and it is both one-to-one and onto at the same time. It is one-to-one and it's also onto at the same time. That is, let's say we have E, let's say you have F. So let's say this one is mapped to this here. Let's say this one is mapped to another thing. This one is also mapped to another thing here. I do now. So arrow, arrow, arrow. I get it now. All right. So now this is bijective. Reason me that it is both one-to-one and also onto. That is, one-to-one means each element here has their own separate images. I do now. So it is one-to-one. What about onto? Every element here must be mapped to something. Every element here must be mapped to something here. Now. So B is mapped to something here, D is mapped to something here, F is mapped to something here. So it's also one-to-one. So when it is both one-to-one and onto, then we call it a bijective mapping. So these are the major three kind of mapping. There are many more, but these are the major three kind of mapping that we have under this subject of what mapping. So in the next video, I'll look at functions, and then from there we'll write them. So see you in the next video, but don't forget to subscribe and also share to those in need. All right.